Orientation and navigation. 1. To South Americans, robins are birds that fly north every spring. To North Americans, the robins simply vacation in the south each winter. Furthermore, they fly to very specific places in South America, and will often come back to the same trees in North American yards the following spring. The question perplexed people for years, until, in the 1950s, a German scientist named Gustav Kramer provided some answers and, in the process, raised new questions. Kramer initiated important new kinds of research regarding how animals orient and navigate. Orientation is simply facing in the right direction. Navigation involves finding one's way from point A to point B. Early in his research, Kramer found that caged migratory birds became very restless at about the time they would normally have begun migration in the wild. Furthermore, he noticed that as they fluttered around in the cage, they often launched themselves in the direction of their normal migratory route. He then set up experiments with caged starlings and found that their orientation was, in fact, in the proper migratory direction except when the sky was overcast, at which times there was no clear direction to their restless movements. Kramer surmised, therefore, that they were orienting according to the position of the sunday. To test this idea, he blocked their view of the sun and used mirrors to change its apparent position. He found that under these circumstances, the birds oriented with respect to the new sunday. They seemed to be using the sun as a compass to determine direction. At the time, this idea seemed preposterous. How could a bird navigate by the sun when some of us lose our way with road maps? Obviously, more testing was in order. So, in another set of experiments, Kramer put identical food boxes around the cage, with food in only one of the boxes. The boxes were stationary, and the one containing food was always at the same point of the compass. However, its position with respect to the surroundings could be changed by revolving either the inner cage containing the birds or the outer walls, which served as the background. As long as the birds could see the sun, no matter how their surroundings were altered, they went directly to the correct food box. Whether the box appeared in front of the right wall or the left wall, they showed no signs of confusion. On overcast days, however, the birds were disoriented and had trouble locating their food box. In experimenting with artificial suns, Kramer made another interesting discovery. If the artificial sun remained stationary, the birds would shift their direction with respect to it at a rate of about 15 degrees per hour, the sun's rate of movement across the sky. Apparently, the birds were assuming that the sun they saw was moving at that rate. When the real sun was visible, however, the birds maintained a constant direction as it moved across the sky. In other words, they were able to compensate for the sun's movement. This meant that some sort of biological clock was operating, and a very precise clock at that. What about birds that migrate at night? Perhaps they navigate by the night sky. To test the idea, caged night migrating birds were placed on the floor of a planetarium during their migratory period. A planetarium is essentially a theater with a dome-like ceiling onto which a night sky can be projected for any night of the year. When the planetarium sky matched the sky outside, the birds fluttered in the direction of their normal migration. But when the dome was rotated, the birds changed their direction to match the artificial sky. The results clearly indicated that the birds were orienting according to the stars. There is accumulating evidence indicating that birds navigate by using a wide variety of environmental cues. Other areas under investigation include magnetism, landmarks, coastlines, sonar, and even smells. The studies are complicated by the fact that the data are sometimes contradictory, and the mechanisms apparently change from time to time. Furthermore, one sensory ability may back up another.